Welcome to this lesson on the reactivity series. We are going to explore how metals are arranged according to their reactivity, their reactions with water, acids, and steam, and why some appear unreactive. The reactivity series is a list of metals arranged from the most reactive to the least reactive. It helps us predict how metals will react with water, acids, or other compounds. Always remember that the higher up a metal is, the more easily it reacts. At the very top of the series, we have the most reactive metals. These are potassium, sodium, and calcium. They react very strongly, especially with water. Below calcium, we find magnesium and aluminium. Although aluminium is high in the series, it does not seem to react quickly because of a protective oxide layer. Carbon is included to compare metals with a non-metal. Exam tip: remember, carbon and hydrogen are often added to help compare metal reactivity. In the middle of the series, we have zinc, iron, tin, and lead. Then comes hydrogen. Hydrogen is not a metal, but it is included to compare how metals react with acids. At the bottom of the series, we have copper, silver, and gold. These metals are very unreactive and are often called noble metals. This explains why gold and silver are used in jewelry, because they do not corrode easily. Let's summarize the order from the most to the least reactive. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold. Try remembering it with a mnemonic. Please stop calling me a careless zebra, instead try learning how copper saves gold. Let us now look at how metals react with water. Potassium, sodium, and calcium all react with cold water. For example, potassium reacts explosively with water, releasing hydrogen gas and forming an alkaline solution. Magnesium does not react with cold water, but it reacts with steam. The reaction produces magnesium oxide and hydrogen gas. This shows magnesium is less reactive than calcium, sodium, or potassium. Metals like magnesium, zinc, and iron react with dilute hydrochloric acid to produce hydrogen gas and a salt. Copper, silver, and gold do not react with dilute acids. Exam tip: if there is no fizzing or bubbles of gas, the metal is not reactive with acids. The position of a metal in the reactivity series explains its behavior. Metals high in the series react strongly, while those low in the series hardly react at all. A displacement reaction happens when a more reactive metal pushes out a less reactive metal from its compound. For instance, a reactive metal like iron can replace copper from copper sulfate solution. Let's look at an example. When an iron nail is placed in a blue copper sulfate solution, the blue color fades and brown copper forms on the nail. This happens because iron is more reactive than copper. Exam tip: always remember, a reaction only occurs if the metal added is more reactive than the one in the compound. Here's another example. When silver metal is placed in a copper sulfate solution, no reaction occurs. This is because silver is less reactive than copper. Silver cannot displace copper from its compound, so the blue color of the solution remains unchanged. Lastly, when zinc is added to a lead nitrate solution, a reaction takes place. Zinc is more reactive than lead, so it displaces lead from lead nitrate to form zinc nitrate and solid lead. You will observe gray lead forming on the zinc metal and the solution losing its color. Exam tip: Always check the reactivity order before predicting displacement. If the added metal is lower in the reactivity series, no displacement will occur. Let us solve an exam past paper. Question 1. The table gives some observations about the reactivity of 4 metals with dilute hydrochloric acid. Put the 4 metals in order of their reactivity. Put the least reactive metal first. In question 2, you are asked to state why this displacement reaction takes place in the reaction between iron and copper sulfate. Write a symbol equation for the reaction. You can pause the video and give it a try. Here are the answers to the questions. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with ACE students. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.